So the concept that this experiment demonstrates is just solutions and solubility. Solubility is the amount of solute that can be dissolved in solvent, and a solution is just solute and solvent together. So in this experiment, I have some water as my solvent and my salt as the solute. And solutes can be solids, liquids, or gases. And in this case, I am using a solid, which is salt. So this experiment is pretty simple. You need a cup, you need some salt, and then you need some water. So what I'm about to do, I'm about to take this salt, I'm gonna pour in the water, and I'll mix it, and we'll see what happens. So I got my spoon. So I'm about to pour this salt to our water. And if you look at the cup here, you can still see the solid salt here at the bottom. So when I start mixing, so when I mixed the salt and the water, we could see that the salt eventually becomes less and less visible. I just skipped because it was taking too long. So here's our water and salt solution, and you basically just can't see any more of the solid salt anymore. So this process is called dissolution, in which the solute has dissolved in the solvent and results in what we have here, our solution. And also notice the color change. So the salt didn't go anywhere. Our water used to be transparent and now it is somewhat translucent. So we know that our dissolved salt has distributed quite evenly around the volume of water we have. So it's definitely still there. So what happened to the once solid salt that we had in the beginning? We can't see the solid salt anymore because its bonds were broken by the water molecules. The molecules in water are held together by covalent bonds, in which electrons are shared between atoms, and covalent bonds are very, very strong compared to the bonds that were holding together our solute. The bonds in the salt molecules are called ionic bonds, and ionic bonds are basically bonds in which atoms donate electrons to other atoms rather than sharing them. And ionic bonds form between metals and nonmetals, just like salt, Na and Cl. And covalent bonds form between two nonmetals, which was our water, our H and O, two nonmetals. So we have our periodic table of elements. So our ionic bonds, we have our metals. Get the Na right there. And we have our nonmetals. We got the chlorine right there. And we also have our two nonmetals for the covalent bond. We have our hydrogen and our oxygen. And because covalent bonds in the water molecules are much stronger than the ionic bonds of the salt, the water molecules can essentially just pull apart and break the ionic bonds that hold the salt molecules together, which results in our salt dissolving and losing its solid form while in the water right here. So that's basically the chemistry behind this very, very common procedure, pretty much in all cooking. And it can also apply to different salts as well, just like our solubility chart shows that all salts are soluble in water. That's it.